The degree of the expression on the left-hand side is 2021. R of z is linear. Its degree is less than 2. So we have to be able to generate this power of 2021 by multiplying these two terms, which means q of z has a degree of 2019, because we can multiply z to the 2019 power times z squared over here to get z to the 2021 power. Also, since the leading coefficient over here is 1, and we have a leading coefficient over here that's also 1, q of z needs to have a leading coefficient of 1. So q of z is going to start looking something like this. Z to the 2019 power plus some other terms. Let's take q of z and multiply it by z squared plus z plus 1 and see what we get so far. First, multiplying through by z to the 2019 power, we get z to the power of 2021 as expected, but then we also get z to the power of 2020 and z to the power of 2019. We like this, but we don't want these two terms. To get rid of those two terms, why don't we let q of z be equal to z to the 2019 power, and then we'll subtract z to the power of 2018 and see what we get. Multiplying by z squared plus z plus 1, we're going to get our first three terms, same as before. And then as we multiply through by minus z to the 2018 power, we're going to subtract z to the 2020, z to the 2019, and z to the 2018. We'll end up with z to the 2021, which is what we want. These other terms will cancel, and we'll be left with z to the power of 2018, and we don't want this. So we're going to try to cancel that out one more time by adding another term to q of z. Since we're multiplying by a z squared term, let's add z to the power of 2016. Multiplying again by z squared plus z plus 1. When we multiply by our first two terms, z to the power of 2019 minus z to the power of 2018, we'll get the same first two terms as before. So I'll just copy that down from the previous line. And then we'll continue on by multiplying by z to the power of 2016. We'll end up with a positive z to the 2018, z to the 2017, and z to the 2016. Combining like terms, this cancels, and we're left with these two terms that we don't want. But I think we can see that we'll be able to get rid of this z to the power of 2017 by adding in a z to the power of 2015 in our polynomial. So it'll look something like this. And then we're going to subtract z to the power of 2015 and so on. Let's see if we can see the pattern and go straight to the end of our polynomial without having to write out all the terms. We notice that 2019 is a multiple of 3. So we're looking at pairs of powers that are equivalent to 0 and 2 mod 3. So if we go straight to the end, our last few terms are going to be z cubed and then minus z squared. And then we'll skip z to the first power, and then we'll have z to the 0. Let's figure out what happens when we take this version of q of z and multiply it by z squared plus z plus 1. First of all, we're going to get z to the power of 2021. All the intermediate terms are going to disappear. And then let's see what happens when we multiply by z cubed minus z squared plus z to the 0 power. So multiplying through by z cubed, we get z to the 5th, z to the 4th, and z cubed. And then multiplying through by minus z squared, we're going to have a minus z to the 4th, minus z cubed, minus z squared. And then this is 1. So multiplying through by 1, z squared plus z plus 1. Combining like terms, we get z to the 2021. All the intermediate terms are going to cancel out, including the z to the 5th, z to the 4th, z cubed, and z squared. And we're just left with z plus 1. Recall that we want this to be equal to z to the power of 2021 plus 1. This r of z is going to enable us to get rid of the z so that the left and the right-hand side are equal to each other. So we have r of z is equal to negative z, and that is option A.